Okay, now let's talk about separation processes. We're gonna talk about the basic of what is separation processes and how it differs from other physical processes. So let's think about two mixtures. Yes, let's talk about there's two kind of mixtures. The first one is heterogeneous mixtures. For example, you have salt, crystal salt, or salt um, with rock salt with a sand, and if you mix it together, in it's gonna be heterogeneous mixture, sorry, because what you can see in the salt crystal and the sand, you can still see the particles of the sand, but also you can see the particles of the salt mixture. So that is called heterogeneous mixtures. On the other hand, another homogeneous mixture is called, for example, air. So air is basically comprised of 21% of oxygen and 79% of nitrogen. You can't see and you can't separate it straightly about the air. So 21% of oxygen and 79% of nitrogen. So it is called homogeneous mixture. So, the separation of heterogeneous mixture is it is actually it is visually different, and it also has the different physical chemical properties. For example, the density of the sand is different with density of the salt, for example, and it is easy to separate. We can use centrifuge, we can use strainer, yeah, or in Indonesia we called it ayakan, or we can separate it. The difficulty is actually there's a big amount that need to be separated. So we usually use mechanical force, for example, a strainer or a centrifuge, like I said before. Now, for homogeneous mixture, visually it doesn't look like mixture, so it looks like one phase. So you can see just the air or the smoke, and it actually form different physical chemical properties that is differ from the components. For example, if you have a mixture of salt and if you have a mixture of air, it will have different physical chemical properties compared to only pure oxygen or pure nitrogen, for example. And it's also difficult to separate it, so uh, it will be able to be separated by utilizing the diffusion process. Now we talk about mass transfer. What is mass transfer? Mass transfer is the net movement of a species in a mixture from one location to another. There are two mechanisms of mass transfer. The first one is molecular diffusion. So if we think the particle is like we have a lot of random movement. Molecular diffusion is actually caused by random and spontaneous microscopic movement of molecule as is a result of thermal motion, and it also caused by eddy turbulence or eddy diffusion using by random macroscopic fluid motion. So we use the utilization of diffusion because the diffusion process can utilize the difference of the rate of diffusion of a compound in a medium. Let's say we have two compound A and compound B. It will have different diffusion rate, so we can separate it using those different properties. The second one, also diffusion process, can utilize interphase diffusion that leads to equilibrium. At equilibrium, it generally have different composition at different phases. Now let's take a look at this graph. So let's say we have a mixture A and B, and A and B mixture is forced to break through a separation medium, for example membrane, and on the separation medium the diffusion of A is much faster compared to the diffusion rate of B. So what happened at the other side of the membrane, you will have concentration A would be much higher compared to concentration of B. So then we can majorly separate A from mixture A and B. Of course, the driving force will be needed to make this phenomena happen. Now, for the diffusion of species A with respect to B will occur because of driving forces. So what is the driving forces? It can be a concentration gradient, it can be pressure, it can be temperature, or it can be charged particles. So the utilization of interphase diffusion is actually if we have two phases, for example, between water and oil, yeah. If we add separating agent, so the separating agent will cause the mixture to be two phases, for example, alpha phase and beta phase. So A and B will diffuse towards the equilibrium state, and the composition of equilibrium would be different. So the key separation for this case is the equilibrium phases and also the suitable separating agent. The separating agent can be mass or can be another phase, yeah, or it can be also energy.